Hi, lesser known math fans. Today we will look at one surprising fact that I didn't know until recently. If f of n is the product of all divisors of the number n, then it turns out that this function is injective, which simply means that f of n cannot be equal to f of m if n and m are different positive integers. We will see why this is the case now. First, let's do something smart and let's just look at this product of two products. So the first one is the actual f of n, so that's f of n, but the other one is pretty much the same, so each term here is n over d instead of d. However, when d goes over all the divisors of n, then n over d goes over all the divisors of n too, as we know. So basically, the second product is f of n again. Okay, so this is f of n too. So on one hand, if we multiply these two products, we will get f of n squared. On the other hand, we can just write them as a single product, right? So this is product of d times n over d for all the divisors d of n. Of course, we can cancel these out. We see that we will multiply n by itself a bunch of times. So how many times? Well, whatever number of divisors n has. The standard way by tau of n, then this means that this last product will simply be n to power tau of n. Okay, very good. So basically we got a formula for this function f of n, right? So we will see how this would help us now to establish what we want. So what we got was that f squared of n is this n to tau of n. Then f of n is simply n to tau of n over 2. Then okay, if we assume that it's actually possible f of n to be f of m for n and m different, then we must have this equality here. Okay, why is this not possible? Well, first of all, we should note that n and m must have the same prime divisors. Of course, if p divides n, then p must divide m too, and vice versa. So if these are the prime decompositions of the two numbers, then we must have this equation. Alpha I times this exponent must be beta I times that exponent. And this must be true for all alphas and all the corresponding betas. In other words, this alpha I over beta I is the same constant. Same for all I from 1 to s. If m is greater than n, as we can assume, then what this means is that the betas are always greater than the alphas and the ratio is the same. Okay, but if the betas are always greater than the alphas, then this simply means that every divisor of n is also a divisor of m, but not vice versa, right? So there are some divisors of m which won't be divisors of n. But then it's not possible for the two numbers to have the same product of divisors, right? That's simply impossible. So that's a beautiful argument here that completes the proof of this pretty interesting fact.